Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive tutorial on backing up your game's data to prevent the dreaded self-destruct scenario, data corruption, accidental deletion, or catastrophic failure. We'll cover various approaches, code examples, primarily in Python, adaptable to other languages, and best practices. Why backups are crucial. Imagine years of work poured into your game. Players have built worlds, achieved milestones, and accumulated valuable items. Now, imagine losing all of that in an instant due to hardware failure, a hard drive crashes, software bugs, a flawed update corrupts save files, accidental deletion, a misplaced click or a rushed script wipes out data, security breaches, a hacker compromises your system and destroys data, ransomware, your data is encrypted and held hostage, natural disasters, fire, flood, or power surge destroys physical storage. Backups are your safety net. They are the recovery plan that allows you to restore your game to a functional state after a disaster. General backup strategies. There are two main strategies. 1. Local backups, backing up data to a separate location on the same device or a directly connected device, external hard drive, USB drive. Fast and convenient for quick restores. 2. Remote backups, backing up data to a cloud storage service or a separate server. Provides protection against local disasters. Combining both is often the best approach. What data to back up? Save files, these are the most crucial. They contain player progress, world states, character data, inventory, and everything else players have worked for. Configuration files, game settings, preferences, resolution, key bindings. Game assets, art assets, textures, models, sounds, music, scripts, level designs, and other content that defines your game. If your assets are under version control, like Git, backing them up directly may not be necessary, but ensuring your repository is safe is crucial. Database, if your game uses a database to store player data, ensure regular backups of the database are performed. Game executable, backing up the compiled game executable itself can be helpful, especially for older versions of your game that you might want to revert to for testing or historical reasons. Backup frequency. The frequency of your backups depends on how often the game data changes and how much data loss is acceptable. Critical save data, backup frequently, example every hour, or even more frequently if your game uses frequent auto-saves. Configuration files, backup whenever the configuration changes. Game assets, backup after significant changes, example after adding new assets, modifying levels, or updating scripts. If using version control, back up your repository regularly. Database, follow your database's recommended backup schedule, which might involve daily full backups, incremental backups, and transaction logs. Backup rotation, keeping multiple backups. Don't just overwrite your last backup each time. Use a backup rotation scheme. This means keeping multiple backups from different points in time. If a recent backup is corrupted, you can restore from an older, hopefully good, backup. Grandfather father-son, GFS, a common rotation scheme. Son, daily, keep a backup for each day of the week. Father, weekly, keep a backup for each week of the month. Grandfather, monthly, keep a backup for each month of the year. Other rotation schemes, tailor the rotation to your needs. You might keep daily backups for the last week, weekly backups for the last month, and monthly backups for the last year. Backup compression. Compress your backups to save storage space. Use a compression algorithm like zip, gzip, or 7z. Backup encryption. If your backups contain sensitive data, example player account information, encrypt them. Use a strong encryption algorithm like AES. Backup verification. Don't assume your backups are good. Regularly verify them. This means restoring a backup to a test environment and checking that the data is intact and the game functions correctly. Code examples, Python. These examples are designed to be adapted. Remember that the specific paths and data structures will vary depending on your game. 1. Simple local backup, file copy. Explanation asterisk. Asterisk shuttle.copy2, copies the file while preserving metadata, timestamps, permissions. Use shuttle.copy, if you don't need to preserve metadata. Asterisk timestamping, adds a timestamp to the backup file name to prevent overwriting. Asterisk error handling, includes a try, except block to catch potential errors. Asterisk directory creation, os.makeDirs, creates the backup directory if it doesn't exist. 2. Zipping a directory for backup, local or remote. Explanation asterisk. Asterisk shuttle.make_archive, creates a zip archive of the directory. The format parameter specifies the archive type. Asterisk os.path.splytext, zip_path, 0, this removes the .zip extension temporarily so make_archive can create the archive. The zip archive is then named correctly using the zip_path. Asterisk timestamped file name, includes a timestamp in the zip file name. 3. Rotating backups, basic example. Explanation asterisk. Asterisk glob.glob, finds all files matching a pattern, example star.zip, in a directory. Asterisk os.path.getTime, gets the modification time of a file, used for sorting. Asterisk file deletion, os.remove, deletes the oldest backup files. Important notes about rotation asterisk. Asterisk adaptation asterisk the rotation scheme, how many backups to keep and for how long, depends on your specific needs. Asterisk more sophisticated rotation asterisk for GFS or other more complex rotation schemes, you'll need more elaborate logic to categorize backups by day, week, month, etc. Consider using a library like dateutil for easier date/time calculations. 4. Database backup, example using SQLite. Explanation asterisk. Asterisk SQLite3.connect, connects to the SQLite database. Asterisk con.backup, creates a backup of the database. Asterisk important, close connections to release resources. Database backup notes, general. Asterisk other databases asterisk for other database systems, MySQL, PostgreSQL, MongoDB, etc., use the appropriate database-specific backup tools or libraries, example miscldump for MySQL, pg_dump for PostgreSQL. Asterisk consistency asterisk ensure that your database backup process guarantees data consistency. This might involve briefly locking the database or using transaction logs. Asterisk database specific tools asterisk database systems often provide built-in backup and restore utilities that are more robust and efficient than simple file copies. Use them if available. 5. Encryption, using PyNACL. Explanation asterisk. Asterisk encryption library asterisk I used PyNACL. You may need to install it. Pip install pynacl. Asterisk key generation asterisk securely generate a key. This example shows generation. Never hard code a key in your game code. You need proper key management. Asterisk nonce asterisk a unique nonce, number used once, is essential for security when using symmetric encryption. Asterisk encryption / decryption asterisk the secret box is used for encryption and decryption. Important encryption considerations asterisk. Asterisk key management asterisk the biggest challenge is securely storing the encryption key. Asterisk never hard code keys asterisk never store the encryption key directly in your game code. This is a huge security risk. Asterisk key derivation asterisk consider deriving the key from a password or hardware identifier, but be very careful about entropy and security best practices. Asterisk key vaults asterisk for more complex applications, use a dedicated key vault service, example HashiCorp Vault, AWS KMS, Azure Key Vault. Asterisk performance asterisk encryption can impact performance. Consider encrypting only sensitive parts of your data. 6. Cloud backups, example using AWS S3. Explanation asterisk. Asterisk AWS SDK, Boto3 uses the Boto3 library to interact with AWS S3. Install, pip install Boto3. Asterisk AWS credentials asterisk you need to configure your AWS credentials, access key ID, secret access key, correctly. The easiest way is to use environment variables, AWS_access_key_ID, AWS_secret_access_key, or the AWS CLI. Do not hard code your credentials. Asterisk S3 bucket asterisk you need to have an S3 bucket created. Asterisk upload/download asterisk the upload_file, and download_file, methods are used to transfer files. Cloud backup notes, general. Asterisk other cloud services asterisk adapt the code for other cloud storage services, Google Cloud Storage, Azure Blob Storage, Dropbox, etc. Each service has its own SDK. Asterisk security asterisk secure your cloud storage bucket. Use proper IAM policies to control access. Enable encryption at rest. Asterisk cost asterisk cloud storage costs money. Be mindful of storage costs and data transfer costs. Asterisk network reliability asterisk cloud backups rely on a stable internet connection. 7. Implementing backup in your game loop, example. Explanation asterisk. Asterisk game loop integration asterisk the backup logic is integrated into the game's main loop. Asterisk time-based backup asterisk backups are triggered at regular intervals. Asterisk global variables asterisk the last_backup_time variable keeps track of the last backup time. Best practices summary asterisk. Asterisk automate your backup process. Use scripts or scheduled tasks to perform backups regularly. Asterisk test asterisk regularly test your backups by restoring them to a test environment. Asterisk monitor your backup process. Check for errors or failures. Asterisk document your backup strategy. Make sure that everyone on your team knows how to perform backups and restores. Asterisk security secure your backups. Encrypt them and store them in a safe location. Asterisk multiple locations asterisk store backups in multiple locations, local and remote. Asterisk version control asterisk use version control, Git, for your game assets. Important considerations for real-world games. Asterisk multiplayer games asterisk if your game is a multiplayer game that relies on a central server to store player data, you'll need to implement backups on the server side. This might involve backing up databases, server configuration files, and any other data that is necessary to restore the game server to a functional state. Consult with a database administrator. User interface, UI. Create a user interface to allow players to manually trigger backups or restores. Progress bars. Display progress bars during backup and restore operations to provide feedback to the user. Error messages. Display informative error messages if a backup or restore operation fails. Error logging. Log all backup and restore events, including errors, to a file or database for auditing purposes. Consider user expectations. If a backup process takes a very long time, make sure you properly notify the user beforehand. Cloud saves and platform APIs. For games on Steam, PlayStation, Xbox, or mobile platforms, take advantage of cloud save features and platform-specific backup APIs. These are usually the most reliable and convenient way to back up player data. By implementing a robust backup strategy, you can protect your game from data loss and ensure that your players can continue to enjoy your game even if the worst happens.